Yeah, good morning, students. It's my pleasure to introduce this another important application of this tag, which is nothing but evaluation of a postfix expression, right? So just now I would like to share my screen. Okay, so hope my screen is visible to you. Fine. Yeah. So this is week 6 lecture 2. Oh, that is the evaluation of postfix expression. This is one of the important application of the stack, right? So the summary of the previous CDT is that we had seen the application of the stack, that is a conversion of infix expression to postfix expression, where we have used this stack. So a postfix operation does not even follow the rules of operator precedence. So the operator which comes first in the expression is performed first on the operands. For example, if you are given AB plus C star, so first addition is performed on these two operands A and B. Then on that result and we are performing the multiplication with C. So thus we saw that in postfix notation, operators are applied to the operands that are immediately left to that operands. Fine. So now today's topic for discussion is that evaluation of postfix expressions. So the lecture objective is that this session will develop the students' knowledge on how we can evaluate the postfix expression. In that, how the stack can be used. Outcome of this session is that after completion of this session, students will be able to develop the code for evaluation of postfix expression using stack. So the algorithm for evaluation of the postfix expression is very simple. So we have to create an empty stack and start scanning the postfix expression from left to right direction. If the scanned element is an operand, push it into the stack. So here you have to observe that in the postfix expression evaluation, we are making use of a stack to store the operands, not the operators. So in the conversion, we have used the stack to store the operators, but here we are storing the operands we are storing. This is the operand stack we are using in the evaluation of postfix expression. Whereas in the conversion of infix to postfix, we are using operator stack. So this is operand stack, we are using that. So if the scanned element is an operand, we have to push that operand into the stack. So if the scanned element is an operator, so pop the topmost two operands, say operand A and operand B, then apply the respective operator like this, operand B, then operator operand A, and whatever the result we will get, then we have to push it back onto the stack. Okay, so when the expression is ended, the value in the stack is the final answer. So we will take an example here. So for example, this is what we have given it as 2, 10 plus 9, 6 minus slash. So these 2, 10, 9, 6, these are the operands, okay, and this plus minus slash are the operators. So we are scanning this expression from left to right direction till we reach to the end. So because we are scanning first 2, so it is an operand, we have to push that operand into the stack. Then next we will scan this, so 10, so again it is also an operand, we have to push into the stack. So then we are going to get here, this is the top, fine, in the stack, operand stack, 2, on top of that 10 we have stored that. Then next we are scanning this, that is nothing but plus, we are getting that. So once you have scanned it is an operator, then you have to pop the topmost operands. So then pop 10 and pop 2, then apply this the operator plus like this, whatever you have popped listed that will comes first, then plus 2 plus 10. So not like this here. So 10 plus 2, it should not be applied like this. 2 plus 10 only you have to apply. So what is the latest you have popped is 2 is the latest you have popped. So 2 plus 10, then 12. 12 you have to push into the stack again. So this is again what we are calling it as a top. Fine. Then next scan 9. So operand, push it. So on top of 12, 9 will be there. Next 6 we are scanning. Then again it is an operand, push it. So then we are scanning next minus, which is an operator. Pop this topmost two operands. So pop 6, pop 9. So latest we have popped is 9. So we have to apply 9 minus 6, not 6 minus 9. Please try to understand here how we are applying that. So what is the pop, latest pop we have done? 9 minus 6, 3. So again this 3 has to be pushed. So we will push that 3 into the stack. Now this is a stack 3 and then 12 will be there. Then next we will scan this minus, that is slash. So once we have the slash, you have to pop these two operands 3 and 12. So you have to apply 12 slash 3, so which is nothing but 4. So you have to push this 4 into the stack now. So then you have to scan here. So we have reached to the end of this expression. So once we reach to the end of this expression, so now what is the value that is there in the stack? So we have the value 4. This is what we will pop and we will project it as the result of this particular expression, postfix expression evaluation. The result we will get it as answer is 4. Fine. This is how we are using the stack to store the operand values and how we are evaluating it. So this is what the program is here. Okay, so push operation and then pop operation, and we are reading that expression, postfix expression in the form of a character array. We are reading that. Okay, so based on that, if it is not equal to null, so we are checking if it is a digit. Then what we are doing, we are converting it into a what we are calling it as number format. We are converting into that, and we are pushing that number. So because here stack we are using it as a number stack. Fine. Is it clear? Because it is a character now. So 9 will be stored in the form of a character. So it is converted into a integer value. So 0 will be stored in the form of a character. So you have to convert it into the integer equivalent. So 0 ASCII code is 48. So that is the reason what we are using here is that 0's ASCII code minus 48. If you do that, actual integer equivalent value you get it as. So that value we are pushing here. Okay. So if it is not a digit, then we are popping, it is an operator. We are popping the topmost two operands. N1 is equal to pop, N2 is equal to pop, and then switch based on that operator. If it is a plus, N1 plus N2, you have to perform and store into N3. If it is a minus, N2 minus N1, we have to do that. We have to store into N3. And if it is star, we have to perform N2 into N1. We have to store it into N3, and if it's a slash, we are doing that, and then finally we are pushing N3 value onto this stack, and then E plus plus, then we are moving the pointer to the next. So this while loop is repeated until we reach to the end of the expression. So once after you reach to the end of the expression, we will come out of the while loop. After that, the result of the expression is equal to, we have to pop from the stack and display that value. Only one value is there in the stack. Fine. So this is what the program is. So this is the reflections part. Evaluate the following postfix expression using the algorithm. Fine. Assume that each digit is a operand. Each digit is one operand. Okay. So if you are not able to answer that question, please refer or watch this video from the beginning. So the lecture outcomes are revisited here. After completion of this session, students will be able to evaluate the given postfix expression by making use of the stack. Fine. So summary of the student session is that we have used the operand stack for evaluation of the postfix expression. So we are creating an empty stack and start the scanning of the postfix expression from left to right. So if the element is an operand, push it into the stack. If the element is an operator, pop the topmost two operands and calculate the respective, apply the respective operation or operator in this particular order and push the result back onto the stack. So this process should be continued until we reach to this expression. When we reach it to the end of the expression, then the final value which is stored in the stack is your required answer for that particular expression. Fine. So this is what we have seen that. And coming to this lecture level practice problem for this today's session. So these are the two problems. So evaluate the following postfix expression using the algorithm. Fine. So these are the further readings on this particular topic. Fine. So if you have any doubts, please refer this particular further readings. Fine. So thank you. Thank you, one and all.